Okay, good morning, everybody. I'm going to be admitting people as they join the webinar. So sorry if I seem a little bit distracted here, but I think we're going to get started. I'd like to begin by welcoming everybody to this special summer edition of Trainee Talks. Trainee Talks is a monthly webinar series showcasing the research topics of our graduate students in their area of interest related to software engineering and AI. My name is Loic, and I'm the program coordinator for CREATE at Concordia University, and I'll be moderating the webinar today. Today, we are very pleased to have CREATE trainees Afiya and Patrick with us to deliver their talks. Afiya Fahmida Sarah is an MSc candidate in computing science at University of Alberta under the supervision of Dr. Sarah Nadi. Afiya received her Bachelor of Science degree in Computer Science and Engineering from the Military Institute of Science and Technology in Dhaka, Bangladesh. She also worked as a software engineer at Infolytics, an innovative AI development company, before coming to Canada to pursue graduate studies. Afiya will present her thesis research on improving API documentation quality through identifying missing code examples. Afiya will defend her thesis next week, and we wish her all the best in her new ventures. Immediately following Afiya's presentation, we will hear from Patrick Loic Foalem, a third-year PhD candidate in the SWAT lab at Polytechnique Montreal, under the supervision of Dr. Foalem. Patrick's research interests lie in mining software developers' knowledge to uncover insights into software development processes, which can be used to guide the development of trustworthy and responsible AI systems. Patrick holds BSc and MSc degrees in software engineering from Université des Montagnes in Cameroon and continues to give lectures there in his free time. Today, Patrick will be presenting his work on studying logging practice in machine learning-based applications. This webinar is being recorded and will be available to view on our CREATE website at se4ai.org and also on our YouTube channel. So I'll ask that you please keep yourselves on mute until the Q&A session at the end of each speaker. So with that, I'd like to turn things over to Afiya. Afiya, please take it away.
Thank you so much, Lori. Can you see my screen? Hi, everyone. I'm Afiya Fahmida Sarah. Today, I'll be presenting my work on improving software documentation quality through identifying missing code examples. The documentation of software libraries is an essential resource for learning how to use the library. There has been many previous studies that agree that documentation helps the library stakeholders, such as the client developers, to understand the library better. So there can be different types of documentation, such as architectural documentation, design documentation, and requirements documentation. In our study, we focus on the library documentation that are targeted for the end users, that is the client developers who want to learn the library APIs and their usages. Our goal in this study is to bridge the gap between the library developers and the client developers by identifying places in the documentation that can be improved and letting library authors know about these places to improve the documentation quality. There have been previous studies where different quality aspects of documentation have been mentioned. Among them are having code examples, up-to-dateness and correctness of the documentation, readability, navigability, etc. But all these studies agree on one fact that having code examples is the life of developers. For example, in a study done by Robillard, 55% of the 80 respondents say that they used code examples as their API learning strategy. And in another interview by Tan and Nadi, one of the respondents said that code examples, I think, is the thing that I would love to see the most. So on that, we focus on finding missing code examples in a documentation to identify the places which can benefit from having code examples to improve the documentation quality. So I'll be showing you a motivating example here. So this is an API reference page of one of the API of Pandas library. We see that this API does not have any code examples. But upon looking into Stack Overflow, we see that there is a post where the author is having a hard time figuring out the meaning of the parameters of this API. The person is asking if what is the meaning of the parameter bias of the API pandas.core.exponentially moving window.var. If we can convey this information to the library authors, this can be an opportunity for the library developers to know where they lack in their documentation, and they can improve the documentation by adding a code example to this API. So our strategy for improving documentation quality is first, find the library APIs that do not have code examples in the documentation. And second, determine which of these APIs users struggle to use, such as adding a code example for this API would improve the API documentation quality. We create a pipeline. We define a pipeline where our whole approach, the strategy that we described, is implemented. So our pipeline has 4 steps. In the first step, we find the library APIs that do not have code examples in the documentation. That's the first strategy. And in the next 3 steps, we determine which of these APIs without example users struggle to use, and as such, adding a code example for this API would improve the API documentation quality. I will explain each of these steps in detail in the next few slides. First, let's start with detecting APIs without examples. That is the first part of the pipeline. So to detect APIs without example, we first detect the documented APIs from a documentation. So for example, this is a documentation API reference page of request libraries. So from here, we would get request.session. This is an API, and another API is request.close. But we do not consider auth insert because those are properties of the class. So to do so, we basically if we look at this example, that this is the API reference page of pandas.series.2 numpy, and this is the corresponding HTML. We parse this HTML structure to look for the DL and DT tag, from where we get to know what the API's fully qualified name is, that is pandas.series.2 numpy, and what type of API this is. This is the method type API. Next, when we have a list of API doc, that is the documented APIs from our API reference page, and we take into account for looking for the APIs without example, all the examples from a documentation website. So after we have all the documentation for, all the examples from documentation, such as this is a code snippet, another, this is a code snippet. From here, we get the APIs without examples are the ones which API doc do not appear in any of these code examples. So for example, here we see that here we have all these APIs in the example except for request.request. This is the first one, and request.patch. So except these two, all of are present. So these two are our API without example. Next, we find out which APIs no example need code example. So our insight is that the APIs that the developers struggle most with that needs code example. So how do we find out which of the APIs the developers struggle most with? To do so, we look at the Stack Overflow to find the information about those APIs. Next, we talk about the next strategy, that is determine which of these APIs users struggle to use, and as such, adding code example would improve the documentation quality. And to do so, we describe the next 3 steps of our pipeline. But before we do so, if you just notice that the second and third step is the pipe has API, that is detect if a Stack Overflow post mentions the API, versus detect if the Stack Overflow post discusses the API. So what is the difference between a post mentions an API and discusses an API? So let me give you an example to show you what's the difference between why do we have two different steps of this pipeline. So in the first post of Stack Overflow, we see that we are looking for the API pandas.getDummies. So here, the person is asking how to create dummies for certain columns in pandas.getDummies. And he says that if I want column A and D to get dummies for not for column B, I used pandas.getDummies. All columns turned into dummies. So they are basically facing a problem with getDummies API, and they mention that in this post. Whereas in another post, let's see that the person is asking, read a large CSV into a sparse pandas data frame in a memory efficient way. Here, the person is asking if I call, he states that if I call pandas.getDummies first to convert the categorical column to ones and zeros, and then to sparse, it takes an absurd amount of time, much longer than I would expect. Other than building the sparse data frame by hand, is there a good way by how to load the sparse CSV directly without eating so much memory? So they are basically facing a problem with memory issues. And although they use getDummies as an initial step, but that's not the main concern of this post. So in the first post, the post mentions the API and also discusses the API, whereas in the second, it mentions but does not discuss. So we want to differ those two, and that's why we have those two pipelines to differ which of the APIs are mentioned and discussed. So let's start with pipe has API. So in detecting if API mentioned in Stack Overflow post, sorry, can you still see my screen? Okay. Sorry. We use a heuristic-based method to determine if a post mentions an API. So there are different ways a post can mention an API. For example, in the first post, we see that pandas.readCSV is mentioned as is. In the second, we see that pandas pivot table is mentioned in a sentence without having any dot or underscore. And in the third, we see that pandas is mentioned as PD, which is a commonly used abbreviation like pd.readCSV. So we consider all these while determining a mention if a post mentions an API. So first, to do so, we look for the fully qualified name or partial name in the title. So this is the title of the Stack Overflow post, and we see that this is we see a mention of the API pandas data frame.plot. And if not found in title, we look for the fully qualified name in the post body. For example, this is the request of session close in the post body. And third, if a post contains the code snippet, we look for the simple name in the post body and the API call in the code snippet, such as this is the simple name of the function request.session.close, and s.close is the called API in the code snippet. So by identifying these three types, we see that say that the post mentions the API. Next, we discuss the pipe discuss API step. That is the third step of our pipeline. To find if the core topic of a Stack Overflow post is a certain API, or if the post discusses a certain API, we try two different approaches. The first one is a heuristic-based approach, and the second is LLM-based approach. So I'll be describing the two in the next few slides. So for the heuristic-based approach, our main idea was if we summarize the post and if the summary of the has the API in the summarization, it is the core topic of the post. So with this idea, our strategy was to take the post body and summarize it using LexRank. Next, we add the title to the summary and look for the fully qualified term in the summary. So if we do find it, then we say that this post is discussed in that. This post discusses the API in that post. Next is LLM-based approach. So to attain the best results, we tried 3 different prompting techniques and evaluate their performances. The 3 prompting techniques are zero-shot prompting, few-shot prompting, and chain of thought prompting. So we tried these 3 approaches, and so now we will show the template for each of these approaches. So first, with the zero-shot template, this was our template that we used to query the LLM model. So first, we say that this is a Stack Overflow post and give the post body, and ask if the main topic of this post this API, and put the fully qualified name of the API, and also ask the LLM to answer in yes or no. So basically, for every question, we want to get a yes or no or true and false answer. Similarly, in few-shot prompt template. So in a few-shot prompt template, we first give two examples. First one is a positive example. So we say that the post is this example one. The example one is the post body, and we say is the main topic of this post this API, and we say that the answer is yes for the first one. This is an example post. In the second example post is a negative one, so we answer with no. And thirdly, we ask the main question, that the one that we want to know from the LLM, that is the post is the post body, and we ask is the main topic of this post this API, and we want the LLM to answer us with yes or no, having the context of the examples that we just gave. And in the third approach, that is the chain of thought prompt, the template would be similar to the few-shot prompting, but instead of just saying yes and no, we give our thought that why is it yes and why is it no for the example one and for example two. And lastly, we ask the same question, that if the post that we want to know is and it is the main topic of the post is this API, and our API with a fully qualified name. So after we finish doing that, we perform an evaluation test. So to do the evaluation, we created a ground truth for a few APIs of the 3 libraries, NumPy, Pandas, and Request, and evaluate the 4 approaches for those in regard to that ground truth. So we found the metrics for those 4, and as we see that from the 4 ones, the few-shot learning has a better result for the F measure, and we also consider accuracy and precision. So even for that precision, we have a better score for few-shot learning. So in that reason, for the third part of the step, we choose LLM-based approach with few-shot learning for the pipe discuss API. And the last step is the pipe prioritize API. So to do so, we filter the list of APIs that we got from the pipe discuss API that has at least 3 Stack Overflow posts discussing them as the list of the APIs that need code example. After we finished evaluating, we on the 3 ground truth, 3 libraries ground truth, we evaluated our pipeline in the wild for 12 libraries, and these are the statistics of the 12 libraries for each of the steps of our pipeline. So if we just focus on the total part, so the APIs no example that have at least 1 Stack Overflow post was 40 APIs, and the APIs that needed example after the prioritization was just 4 APIs that we got from these 12 libraries. So these are the list of the 4 APIs that need example. But after finding this, we were excited to contact the library developers so that they can know that these are the places where they can improve. But looking furthermore into these 4 APIs, we found that for the first one, Pandas Pivot, the 19 posts are actually talking about the wrong API, that the posts mainly discuss Pandas data frame pivot or pandas.pivot table, but not actually pandas.pivot. And for the second one, this is a class A type API. So the 6 posts that we say that actually discusses for one of the properties or classes of the class, such as request.response.iter content or request.response.ok. For the third one, this is a low-level function, so that's why those posts actually talk about some of the other high-level classes of scipy.odr, but not specifically scipy.odr.odr. And in the fourth one, the posts discuss how to resolve this error for various scenarios. So this is basically an error class, and those those posts as an example of how to would not suffice that the library if having a code example for this a class would help the authors that are facing this problem. So why the negative result? For the first one is our goal was to find places in the documentation that need improvement in their example. So we chose to look for the APIs that do not have examples in the documentation as the potential places. But we did not focus on the quality of the example that already exists. However, we see that the popular libraries have a lot of Stack Overflow posts where developers discuss their struggle using an API, but not necessarily with the APIs without example. The second is if a library has a poor documentation or lots of missing code example, it may mean that the library is not very popular, so we don't find enough Stack Overflow posts for those libraries. And the third is not every post that discusses the API really indicates a struggle. So we ask the LLM if a post discusses a certain API. However, not every post that discusses the API is actually indicating a struggle. So for the future opportunities, one would be to focus on the quality of the existing example of the APIs along with the example APIs with no example. Second would be for unpopular libraries. We need to think about other useful resources for finding struggle using their APIs. So maybe look at the issues of the libraries, etc. And the third, we may need to think about different LLM prompts that focus on asking some specific questions. For example, is the author struggling with the API, or would a code example help here, or something like that? That would be more direct than the generic question that we ask using the term discuss or the core topic. So to summarize, we talk about our goal. Then we talked about the strategy, how we can fulfill our goal by identifying code examples and determining which of those need code example to improve the quality. We talk about our pipeline, and we talk about why we get the negative results. And at last, we talk about we propose some solutions for the future studies. Thank you so much, and I'll be happy to answer any of your questions.
Thank you very much, Afiya. Great presentation, very interesting. Does anyone have any questions for Afiya? Jasmine, I see you have your hand raised. Go ahead.
No, I was clapping.
We were clapping.
Yeah. I might need a bit more time to think of a question.
Okay, sure. Samuel, go ahead.
Thank you for the nice presentation, very insightful. I'm just curious. So the part where you give the LLM the prompt with the post, and then you ask if it's talking about like discussing the API topic. You prompted like yes or no, but then for the change of thoughts part, you ask it to give the reason. Because I'm just curious, were there instances where you observe some sort of hallucination where maybe the LLM responded, you give it a prompt, and then you say, is it talking about this API topic? And it says no, but in justifying its response, it kind of talks about some API that does not exist, or some API that is not even totally related to the post in general.
Right. So if I got your question correct, so you're asking, so if the for the chain of thought, if the LLM response is something with a thought other than yes or no?
No, so let's say let's say example 2, for instance, you post example 2, you ask if the main topic is API 2, and then its response no, and maybe in its reasoning it says something like it does not relate to API 2, but rather API 3, where API 3 doesn't exist at all. It's not like an API that exists in real world, like sort of hallucinating. Was there any observation like that? Just curious. We just wanted to.
Uh, I'm sorry, I still didn't understand the main question. So, for the thought, I'm answering with no, and I'm giving a like because this is a reason. So,
Yeah, yeah.
So I think the
My
question
question is in the.
if
sorry,
go ahead.
sorry.
Oh no, Prof. Nadi, you can.
I was just gonna try to see if if I can paraphrase and understand your question. Is that if you've observed, I feel like where the LLM says no, for example, makes up a reason that doesn't make sense, right? So it's hallucinating the reason, while, for example, the post does actually discuss it. Did I understand that correctly, Samuel?
Yeah, exactly. Yeah, exactly.
Yeah. I think that I was referring to the same thing the first time. That's why I got confused. I'm so sorry. So, no, actually, if you just look correctly, more specifically, so I'm asking is the main topic this one? I'm giving my thought, but at the end when I'm asking, I'm just asking answer only in yes or no, right? So. I like till now I did not see LLM answer with something with thought, but just yes or no. So I did not basically judge or analyze if the LLM is giving me a correct reasoning or not. Does that answer your question?
Okay, yeah, it does. Thank you.
Okay, thank you, Samuel. And I think we have time for another question or maybe a couple of quick questions before we turn things over to Patrick. Akalanka, please go ahead.
Yeah. So I got a question about your experiment when you run things in the wild, right? So when you develop your like proof of concept or the ground truth, and when you pass your documentation, you know the HTML structure, right? So you can write your own custom logic to pass the HTML and extract the APIs and discard the parameters. But when you run things in the wild, those 12 libraries, they probably have like totally different HTML structures for their documentation. So how do you like make things work? Do you still go analyze it and try to get things nicely, or do you have some sort of a logic or heuristics that every documentation can be fit into your logic?
So I have a generic heuristic that you're talking about. So that fits our logic. So the 12 libraries that we do evaluate with our pipeline, those have a similar kind of documentation generated by Sphinx. So we actually go through that kind of documentation that have a similar HTML structure, so that it fits into that HTML structure. So that would be easier for us to from that, it's easier for us to determine which of the APIs or examples we are dealing with.
Okay, thanks.
Thank you, Akalanka. Any final questions for Afiya? No? Going once, going twice? Okay. Then thank you very much, Afiya, and best of luck to you.
Thank you so much.
So maybe if you can stop sharing your screen and Patrick, it's your turn. Please go ahead.
All right, thank you. Are you able to see my screen?
Yes, if you could just make it full size,
Yeah.
that'd be great.
All right. Hello, everyone. Thank you for joining. I hope you are all well. Today, I'm going to present one of my research work. The title is Study Logging Practice in Machine Learning-Based Application. You can find this paper online by scanning this QR code. So here is the agenda that we are going to follow today. We are going to have an introduction, then we are going to discuss some related work, and I'm going to present you our study design, then a research question, and I'm going to present some our result and findings, and at the end we are going to have a conclusion. For the introduction part, what is logging in software engineering? Okay, common practice in software engineering is to record runtime information when you are running your application or when you deploy your application in production. So here is how the logging statement that you are going to introduce in your code will look like. You are going to have the verbosity level of the logging. If here, for this example, it is info, but it can also be one or another one. Here you are going to have a static message, and at the end you are going to have a dynamic message. When you introduce this inside your code, when you execute it or when you put it in production, you are going to have at the end a log message. Log message is going to look like this. You are going to have the moment or the date that the logging statement has been executed inside your program, and you are going to have your verbosity level here and static message. At the end, you are going to have information about your dynamic variable. Why logging is important? Logging is important for 4 reasons. Because it is used for various tasks in software maintenance and operation. So it is used for debugging. If there is any problem inside your application, you can use your log message to debug your application. And it is also used for monitoring and also for performance and analysis. And even it is used for anomaly detection, where you can use the AI model to try to detect any anomaly inside your application through log message. Is logging within application challenging? The answer is yes, logging is challenging for 2 main reasons. The first one is if you log too much, you are going to have runtime overhead, storage overhead, and you are going to have too many trivial logs. And the second part is if you log too little, you are going to miss important information, and this is going to increase the difficulty level to try to debug your application in case you have a problem. So what do we call ML-based application? Nowadays, there is a lot of AI model or ML model outside there. Before the arrival of this lot of AI algorithm, we know how to develop application. We have to combine two knowledge, one from software engineering and the other one from computer system. And when we are going to combine these two knowledge, we are going to develop what we call traditional application. But now with this AI or ML model, we are going to add this component inside the traditional application, and we are going to call this ML-based application or AI-based application. This new type of application comes with a lot of challenge, and we can, I try to mention here some of the challenge of this new type of application, ML-based application. It's like some challenge that you can face is data drift or trying to reproduce your result. And there is also concept that we call overfitting, and monitoring and logging are part of the challenge that you are going to have when you develop this type of application. So our research objective here, we have three research objectives. The first one is to try to understand logging practice in ML-based application. The second one is try to compare what is doing in ML-based application in terms of logging versus traditional application. And the third research objective here is to try to explore the motivation behind the use of logging inside ML-based application. So now let's talk about some related work that has been doing in this field. We try to categorize related work that has been published in this week in two categories. The first one is trying to categorize logging practice in traditional applications. So there is many work that has been doing outside there, try to characterize logging practice in different programming language. For example, this study tried to do for Android application, this one for Java-based application, the other one for C and C++ application, and this one try to understand where developer log inside C# application. So the second part, people are now take advantage of AI model to try to help developer in their logging decision. Most recent work and that is doing really good, that is trying to have very good result is this work, where author tried to use a pre-trained deep learning model T5 to mention it, to try to generate a complete login statement inside to try to help developer in generating complete login statement inside your Java application. So now let's talk about our study design. To conduct this study, we start to identify ML logging library from research paper and from CREATE literature. We apply some criteria, and once we have our logging library that are used in ML-based application, we, based on the import configuration of those library, we search for project online that use those library, and then we collect a total of 502 number of ML projects that use those ML logging library. From there, we develop a parser, a Python parser, to try to extract logging statement from those projects. And we were able to answer our two first research questions. Then we further conduct a qualitative analysis that is going to help us to answer our two other research questions. We then conduct a survey practitioner to get insight from them. So our replication package is available. You can try it out by scanning this QR code. Now let's discuss about our research question. For this paper, we try to answer 4 research questions. The first one is, what are the characteristics of logging practice in ML-based application? The second one, what are the most common ML-specific logging library that are used in ML-based application? The third one, which phase of the entire ML pipeline are prone of logging? And the fourth one, why do ML practitioners use logging inside the ML-based application? So now let's move to the research and funding. So for the first research question, what are the characteristics of logging practice in ML-based application? For the first result, we try to compare the prevalence of logging inside ML application compared to traditional application. So we use a log density as a metric to try to evaluate the log density inside ML-based application. So this log density is total number of line of code inside inside a project divided by the number of logging statements. So our first finding here is our study revealed that logging practice in ML-based application are less prevalent compared to traditional application. So the second part of our result for the same RQ is, when we start investigating this, we observe that there is 2 types of logging library that are used inside ML-based application. The first type is ML-specific logging library, for example, MLflow, Waze and By. And the second type is general logging library, for example, logging for Python developer, and the other one I can mention log4j for Java developer. So our first observation here is that inside our project sample, the most introduced login statement is for the one of ML-specific login library. And the second observation is that there is no project that use only ML-specific login library. Half of the project that we analyze use the combination of both ML-specific login library and general login library, and the other half use general login library inside their application. And this observation has been confirmed with practitioners, where 16% of 31 practitioners confirm the fact that they are still using general login library inside your ML application. So our second finding here is traditional application primarily rely on general login library, and the ML-based application use a combination of ML-specific login library and general login library. Now, the third part of our result for the same IQ, we try to see which log level are more used in ML-based application. So we find that info and warning level are the log level that are commonly used in ML-based application. This is an example of where a practitioner tries to use info level to try to use info level inside your logging statement, and here he is trying to record some model information, and the other one is example of use of warning level inside the application. So now let's move to our second research question. Our second research question is, what are the most commonly used ML-specific login library inside ML-based application? So we find here that the most commonly used ML-specific login library inside ML-based application are MLflow, TensorBoard, Neptune, and Waze and By. And these libraries are designed to handle unique requirements of ML logging, including performance metric, model, hyperparameter, and experiment tracking. So for the third research question, we try to look in the entire ML pipeline, which one is prone of logging. So our finding here is that the whole phase of the entire ML pipeline contain at least one logging statement. But ML model training has the largest part, and the ML deployment has the few part or contain the few part of logging statement. We think that there is two reasons for that, because in the model training, we don't have our model ready, so we are going to have intensive experimentation and configuration adjustment. And for the model deployment, we think that it's because here we already have our model ready, so we are trying to monitor the inference performance. That means that we are trying to look if the model that we have trained are still be useful for the task that it has been trained for. And we are trying to detect, trying to do some anomaly detection by monitoring the model. So for the fourth research question, we try to investigate the reason why ML practitioners are introducing login statement. So the finding here is ML practitioners use login statement to record important information during data management, during model management, and during configuration management. I know that maybe the figure is not that clear for you, but here each entity represents a specific step in the ML pipeline, and the attribute represent the reason what information practitioners are logged when they introduce login statement in that phase. So in conclusion, I present what is the definition of logging in software engineering. We discussed and mentioned that logging is very important and it is challenging. We try to answer 4 research questions for this research project. The first one is we try to characterize logging practice in ML-based application and compare with traditional application. And we answer our second research question: what are the most commonly used ML specific logging library. The third one, in the entire pipeline, which phase are prone of logging, and we investigate in our fourth research question the reason why ML practitioner use logging statement inside your application. We define what we call ML-based application or AI-based application. Then from our result, we observe that in ML-based application, people rely on two types of ML logging library compared to traditional application where people rely only on general logging library. So that's it. If you have any question, you feel free to ask me. Thank you.
Thank you so much, Patrick. That was excellent. What is the name of the journal that this paper was published in again?
IST.
IST. Okay.
Yeah.
Great. Thank you. Does anyone have any questions for Patrick? Akalenka, please go ahead.
Hi, Patrick. Thanks for the talk. I got a little bit of a low-level question because this is a common problem that I face. So when you try to identify GitHub projects that use logging libraries, like how do you identify the dependencies? Because I don't think GitHub provides a straightforward way for you to filter out the libraries, right, based on the dependencies.
Yes. Here, what we did to extract project that use ML logging library. So in the first part of our research study, once we identify ML logging library that are used, we try to go inside the documentation of each library. We try to have the import configuration. For example, for MLflow, if import configuration can be import MLflow. So based on the import configuration, there is a way that you can combine the import configuration to search for projects that contain that import configuration. So that's how we were able to collect those projects. Because when you are going to use those configurations, GitHub is going to return you all 5. I think it's 5, not project, but based on the 5, you can get the project.
Let me rephrase my question, right? So if I have 2 libraries that I found in GitHub, let's say 2 projects, project A and project B. Project A doesn't use any of the logging libraries, project B uses one. So by looking at the project A and B, I don't really know anything. So, but if I clone it or just go through some sort of like source files, then I can inspect and see whether any of the import statements matches to the configuration that you're looking for. But without really cloning, you don't really know. But if you look at GitHub, there's probably like millions of projects, right? So I'm wondering, like, how do you get into the project that actually imports these libraries, right? Do you clone everything, that discard anything if it doesn't really import it, how do you do it?
We didn't clone the project before. It is if the project, like I explained it before, based on the import configuration of the library, with the GitHub API, you are able to search, let's say, 5 that are hosted by GitHub that contain that import configuration. Based on the import configuration, if you search for project that contain that import configuration, GitHub is going to return you a list of 5 that contain that import. And from the 5 that contain that import, you can get all the project, and from there you can now try to remove project because it's going to sometime there's going to be sometime duplicate project. Now you can start filtering it out.
Okay. It's a code search part, right? The GitHub search engine.
It is a code search part.
Okay, all right, thank you.
Yeah.
Thank
Yes,
you.
I think
I think Jasmine has a question. So Jasmine, please go ahead.
Thank you, Lori. Thank you, Patrick, for the very nice presentation. So I'm not very familiar with your topic, but I can see some links with the last paper that I worked on. So it was on model management, and one of our findings was that collaborative platforms were not very adapted for the special needs that machine learning projects have. And we know that logging is one of the very important activity of model management because you have to log so many things because of the experimental nature of machine learning projects. So I was wondering, how well adapted are those collaborative platforms to support this special kind of logging that we need for machine learning projects? And if you think that we might need something more than GitHub is able to offer right now. I'm sorry if it doesn't make sense.
No. I try to understand your question. So your question, I think your question is like, if with the nature of AI project, if we need something more than GitHub.
Yeah, because basically a lot of the work in machine learning projects, it happens offline, right? And we need to log a lot of things. So I was wondering how online collaborative platforms can better support that in terms of logging.
I think in terms of logging, there is a ML specific logging library that I try to mention during my presentation. That they are doing interesting thing in trying to in terms of collaborative and in terms of monitoring, because they are offer some new feature that's general logging library doesn't offer. For example, for if you use those library to log, you can visualize all maybe a parameter, and there's an easy way to save those hyperparameter of your model. And they offer also a collaborative environment, so you can work there with in team very easily. And if we look in terms of managing the entire project and going beyond logging, I think that some of those MS specific logging library, for example, of MLflow, is trying to do more than giving just a monitoring or logging of environment.
So with basically those are kind of standalone, I guess, libraries. Do they integrate with other platforms like GitLab or Gitbucket or GitHub? Or it's like their own platform?
I think they have the on platform, but I think there is also the way that you can collaborate with other repository like GitHub that you mentioned. But in terms of ML, I think there is also some new type of repository that people are developing out there to try to manage the entire ML project from data to deployment.
I see.
Yeah.
Thank you.
You're welcome.
I had a quick question, but about one of your graphs, like there was the density graph.
Yeah.
That at the beginning. So logging statement per line of code, so more is better, right?
More here means that there's less logging statement, because the log density is the total number of line of code inside a project divided by the number of logging statement. So for this first one,
it's not the opposite. Okay,
yeah,
so I was
yeah,
confused.
yeah,
Okay,
yeah,
okay,
yeah.
okay. I see. Okay, so yours is the first one, and it's much more than and I guess compared to traditional like Python applications, that's the third piece of work there. It's still it's still much less, because I was just like initially I was wondering maybe just in general Python doesn't have as much logging as other applications, but it doesn't. It still seems there's a big discrepancy, right?
Yeah.
Okay, it was just clarifying the numbers there. Yeah.
All right.
Great, wow. Lots of content that Patrick provided for questions. Does anyone have any more questions for Patrick before we wrap things up? No? Okay, well, in that case, I'd like to thank both of our presenters today and to all 28 participants who joined the webinar. That was great to see so many faces today. We will be taking a little break from Trainee Talks for the rest of the summer. I know I told you in May that was it until the fall, but we really wanted to squeeze in this one, Trainee Talks, for Afiya and Patrick. So really glad we did. And we will reconvene again in September, October for the next Trainee Talks. So thank you so much, everybody. Have a great afternoon and
Thank you.
weekend.
Thank you so much.
Thank you.
Thank you. Bye-bye.
Bye.